Is our universe truly unique, or have countless other universes existed before? The James Webb Telescope has once again detected something that challenges our conventional understanding of the cosmos. The newly discovered galaxy demonstrates that we have been dramatically mistaken about the cosmic dawn. Combined with all the other impossible structures that Webb has already uncovered, more and more experts are turning away from the established Big Bang theory and believe it more likely that our universe actually underwent a completely different development. Roger Penrose is one of them. The British Nobel Prize winner is not only convinced that the cosmos follows an eternal cycle, but also claims to have found concrete evidence for this interplay of destruction and rebirth. Today, we'll show you what the James Webb Telescope has discovered in the depths of space, and which objects could actually originate from a previous universe. Too early, too big, too massive. After the James Webb Telescope scanned a section of the sky near the Big Dipper, astronomers detected some mysterious points of light whose light had been traveling towards us for more than 13 billion years. It came from objects that existed around 500 to 700 million years after the Big Bang, and their characteristics suggested that they were early galaxies. However, the scientists were perplexed to discover that, despite this, the star clusters were already as massive as our Milky Way is today. That should not be possible. After all, our standard model states that there simply was not enough normal matter at that time to pave the way for such galactic heavyweights. Dubbed the universe breakers, these inexplicable structures presented the astronomical research community with serious problems. But that was only the beginning. In the period that followed, Webb detected even more galaxies that appeared far too starry for their age of a few 100 million years after the Big Bang. It also confirmed that the expansion rate of the cosmos does not match our theoretical predictions. More precisely, the corresponding expansion rate is described by the so-called Hubble constant. When we determine this on paper, we get a value of 67 kilometers per second per megaparsec. However, as soon as we consult supernovae, red giants, gravitational lenses, and variable stars, the Hubble constant suddenly becomes 73 kilometers per second per megaparsec. Indeed, Webb should confirm this striking discrepancy again in the course of new observations. But how can this be? How can such an extreme deviation between theory and reality be explained? Merging universes? The most spectacular solution proposed by researchers is the assumption that our universe is currently merging with other universes. After all, the true reason for cosmological inflation, or in other words, the phase of superluminal growth shortly after the Big Bang, could have been that our young cosmos was swallowed up by a larger mother cosmos. To this end, scientists have developed a mathematical model that examines the effects that multiple interacting universes would have on our cosmic world. The bottom line was that such a scenario would increase the volume of our universe, and thus generate an increase in volume that our measuring instruments interpret as the expansion of the universe. At the same time, experts also determined the expansion rate that would be expected in such a case, and were astonished to find that the corresponding results actually agree better with our observations in space than the traditional standard. This Webb discovery is shaking up the cosmic dawn. Many experts now openly admit that our understanding of the universe is incomplete, and that there may be significant factors out there that have so far eluded our gaze. The latest Webb discovery once again shows us how much we still have to learn about the evolution of the cosmos, and that an assumption is only considered established until it is challenged by a contradictory observation. To understand what this means, we have to turn back the wheel of time to the cosmic dawn, and thus enter a phase in which the young stars not only turned on the light in the universe, but also ionized the previously neutral hydrogen. Before that, the interstellar hydrogen clouds had acted like a dense fog, scattering and swallowing ultraviolet and other short-wave radiation, and enveloping the cosmos in darkness. Experts generally assume that the chapter of the reionization began around 300 million years after the Big Bang. Model simulations indicate that the first gaps in the hydrogen nebula were already appearing at that time. However, these regions, which were permeable to short-wave radiation, were still small and only created bubble-shaped zones around early galaxies, because only there had the young stars already ionized the gas. Well, at least that's what we thought, until now. Meet Galaxy Jade's GS Z11-1. Now with Jade's GS Z11-1, the James Webb Telescope has added a galaxy to the star maps that existed just 330 million years after the Big Bang, leaving the research world with raised eyebrows. This is because the star cluster is emitting an astonishing amount of shortwave UV radiation for this era, which, taking into account the redshift of the spectral signature of excited hydrogen, corresponds to what is known as Lyman alpha radiation. But this is problematic, to say the least. After all, the discovery stands in stark contrast to our current understanding of cosmic evolution. The reason for this is that, according to our knowledge, Lyman alpha radiation could only spread once the dense hydrogen nebula had already been ionized over a large area, which, according to the models, did not happen until much later. Astronomer Joris Wittstock from the University of Cambridge, who led the study, explained the confusing discovery as follows. This was completely unexpected. Although we are seeing this galaxy at a time when the universe was only 330 million years old, it shows the surprisingly clear, strong signature of Lyman alpha radiation. His colleague and co-author Kevin Heinlein added, "We shouldn't have found a galaxy like this at all. And yet, there it is." The spectral data leave no doubt that the galaxy's UV radiation reached further than anyone had previously thought possible. The scientists have determined that the bubble of ionized, and therefore UV permeable, gas must have extended over 650,000 light-years in all directions. This, conversely, means that cosmic reionization either began much earlier than expected, or that it proceeded faster than our models suggest. Is this proof of a cyclical universe? However, the discovery also suggests that less massive early galaxies played a greater role in reionization than previously thought. The exact origin of the intense UV radiation from the discovered structure is still unknown. In this regard, scientists point out that the large bubble of ionized hydrogen was either created by a special hot and luminous primordial star population, or by an active black hole at the center of the galaxy. But what do all these confusing findings actually mean for our overall understanding of the universe? If we keep finding more and more things out there that simply do not fit with our models of cosmic evolution, could it be that we are wrong about something much more fundamental? After all, what if the Big Bang did not mark the literal beginning of everything, but merely the explosive transition from one universe to the next? Well, then we would have arrived straight at Roger Penrose's fundamental conviction. Roger Penrose's Big Bounce. The British Nobel Prize winner in physics has no doubt that the cosmos follows a constant interplay of destruction and rebirth, and that the much-cited Big Bang was therefore more of a big bounce. In detail, the universe would constantly expand until all matter disintegrated and turned into light. And true to the motto, what expands can also contract again, this extreme environment, in which nothing has any reference to time or space, would inevitably lead to the universe exploding into a new existence. However, this assumption becomes even more exciting when we consider that Penrose claims to have already found concrete evidence for his cyclical view of the world. In fact, objects originating directly from our precursor universe are said to be slumbering in the depths of space. But what does that mean? Well, Penrose and his colleagues have discovered a striking signal in the cosmic microwave background, or CMB for short. This is a remnant of radiation that originated about 380,000 years after the Big Bang, and still fills the entire universe today. And it's precisely here that Penrose and his colleagues have found circular spots that can be seen in the data from the Planck and WMAP satellites, and which correspond to many times the average CMB temperature fluctuations. According to Penrose, these are nothing other than Hawking points. This means that at the end of every cosmic era, supermassive black holes would completely evaporate into Hawking radiation, taking all the energy they emitted with them into the next universe in the form of such a Hawking point. The photons produced in this process scatter in an expanding region, but they are not released until they finally appear in the microwave background radiation of the next cosmos. There, the Hawking points would then look to us like disks with a diameter roughly equal to that of the full moon. And this is exactly what Penrose has detected in the CMB sky. In other words, these could actually be the places where the black holes of the precursor universe immortalized their Hawking points in the background radiation. Final thoughts. Whether we are really dealing with the real remnants of a previous cosmos remains controversial among the scientific community. But Penrose remains unfazed, pointing out that black holes were once dismissed as pure mathematical speculation and are now undisputed astronomical realities. And if you want our astronomy videos to become part of your reality, you can now simply click on the subscribe button. We'd love to have you join our community so you never miss a new post from us again. We'll see you soon.